Okay, so just letting you guys know, today we're going to talk about the Paleozoic era. Wednesday we'll talk about the Mesozoic. Thursday, or not Thursday, next Monday we'll talk about the Cenozoic era. And then Wednesday, I will probably assign you guys a project regarding the whole thing. But first, we're going to just go over the Paleozoic era. The Paleozoic era, there was both a lot of things happening and not a whole lot of things happening, if that makes sense. Evan, I just got your thing. I will put those in as soon as class is over. So anyway, let's go ahead and I will share my screen with you guys. Okay, so go ahead, pull that over. All right, so we have the Paleozoic era, okay? And so the Paleozoic era spans from about 542 till about 251 million years ago, okay? And a lot of stuff was happening here, okay? This is where we get first vertebrates. Can anybody tell me what a vertebrate is?
They got a backbone.
Yep, they have a backbone, okay? They have vertebrae. You're also going to get your first insects, first land plants, okay? And land plants with seeds, okay? You're also going to get reptiles. Well, first you'll have first amphibians, and first is not with a PH, reptiles, okay? So a lot of stuff is happening in here, okay? The other thing that we're going to have is, during this time, a supercontinent called Rodinia was formed at beginning of Paleozoic era, but by end of it, there was two smaller supercontinents called Gondwana and Laurentia. Okay, and so we have these. This is going to be, if you were just looking for a quick little overview of the Paleozoic era, this is a lot of what is happening, okay? There was a lot of life that, ended up evolving and happening during this time, and then there's a lot of life that ended up going extinct. There were, let's see, 3 main big extinction events throughout this era, okay, that resulted in a lot of losses in terms of life, all right? But this is just kind of that big general overview of the Paleozoic era. A lot of things, this is where you're going to start seeing life that you would recognize, okay? Are there any questions about any of this?
Nope.
Okay, perfect. Thank you. So I'll go ahead and clear this then, unless anybody's writing anything down. All right, and so I won't go too much into it because it's kind of hard to describe over this, but we do have this term that we use called paleogeography, okay, and this is essentially trying to reconstruct and examine past geography on land, okay? So if you go and look up continental drifting over time, you can see essentially Gondwana and Laurentia forming from Rodinia, okay? And it's just a lot of breaking up over time. Kind of by the end of this, going into the Mesozoic era, you're going to get a lot of Pangea begins to form. All right, but this is basically just looking back at that, and we use paleogeography to determine what life or what the Earth was like millions of years ago, and how that how that helped life develop. Okay, and so that's kind of what paleogeography is. Again, just kind of understanding that during this time there was a lot of breakup of continents and shifting of continents. You're also going to have different orogenies that form. Orogenies are going to be where you have mountains being built, okay? Two large, important orogenies that occurred, okay? And this is orogeny is mountain building due to continents colliding. Okay, so the two large ones, okay, and these are both in North America. So you're going to have the Ouachita mountain or orogeny, and these are in basically South America and Africa kind of collided with North America, and this will form the Ouachita mountain range. In kind of like Arkansas, Arkansas. Okay, but this lifted land all the way out to Colorado. Okay, so this was a pretty big one, but it definitely was not as big as the one known as the Alleghenian orogeny. Okay, this created what was at the time the largest mountain range in the world, and it extends on the eastern side of the United States, and it also extended up into what is now Britain and the Scandinavian countries, so like Norway, Sweden, and partially Finland, I believe. But this created the Appalachian mountain range. Okay, and this extends most of eastern US, Britain, and into Norway, Sweden. Okay, I don't want to go too much into the actual how all of this happened because it's, again, kind of hard to explain, but do understand that continents were breaking apart, they were moving, they were colliding and forming all these different mountain ranges at this time. Again, when two crusts collide, that's an orogeny, and it's a mountain building. The largest orogeny that we've had is obviously when the Indian plate bumped into the Asia plate and created the Himalayan mountains, which contain Mount Everest. But anyway, are there any questions about kind of the paleogeography kind of stuff of this time? Again, we don't need to go too far into it. I want to focus more on the life aspect during the Paleozoic time.
I think we're good.
Thanks, Brooke. Okay, so I'll go ahead and clear this. All right. Now let's talk about Paleozoic life. Okay. All right, and we can look at this essentially in it's a timeline. Okay, there's going to be a couple of different periods inside of this era, okay? And so we're going to go Cambrian, and then we'll go into Ordovician, okay? Then we'll go into, and you guys don't need to memorize these, I'm just kind of putting them out there. Silurian, okay, which then leads into the Devonian. Devonian period goes into the Carboniferous. And finally, the Carboniferous will lead you to the Permian. Okay, so those are the periods. Okay, at this point in time, at the very beginning of this, we have the Cambrian period. Right, and the Cambrian period is well known for having what is known as the Cambrian explosion. Okay, the Cambrian explosion essentially was where thousands of new species, probably more in the tens to hundreds of thousands, formed in the oceans, okay? And so we're getting a whole bunch of new stuff. You're going to get a lot of invertebrates, okay? So invertebrates form. Okay, you're also going to get kind of your some really basic vertebrates might begin to form, but for the most part, you're going to have a lot of this. Shrimp and things like trilobites, as well as things like lamprey are really starting to, they're the dominant species throughout this time frame, okay? But the Cambrian explosion really had a whole lot of different organisms. You can see these, they're pretty well captured, okay? Organisms had hard-shelled bodies and created a lot of fossils in shale, okay? And so we can look back through and see in the fossil record that we had a bunch of these different things, okay? Then we need to go into the Ordovician period, all right? In the Ordovician period, this is an important period due to the fact this is where we start getting vertebrates. Okay, we're going to get really primitive fish, okay? These are really going to be the ones that start to form, and so you're going to get primitive fish form. They don't look exactly kind of the way. They're going to be a lot more like bony fish with harder, I don't want to say a shell, but it's almost shell-like with harder exterior than present-day fish. Okay, but we have these very primitive, very basic vertebrates that are forming during this Ordovician period. But the thing you have to remember, during the Cambrian and the Ordovician periods, both of these were pretty much marine only, okay? So marine only. Then during the Ordovician period, we had, at end of Ordovician period, an extinction event occurred, okay? Okay, so the Ordovician extinction is what kind of leads us from the Ordovician period into the Silurian period. And now the Ordovician extinction, this is essentially half of marine life went extinct, okay? And we're trying to figure out basically what caused this, but we do believe that this was due to drastic worldwide drops in temperatures and large portions of ocean freezing up. Now, not freezing up like, you know, you would think, it doesn't go all the way down, but kind of similar to Antarctica where it freezes over the top. That's just going to drop the temperature of the earth or of the oceans to a point where it's pretty darn hard for things to live inside the ocean, okay? But that gets us to our first of 3 extinction events, all right? And now while this is all happening, we do have, like I said, we have Rodinia and Gondwana and Laurentia, these supercontinents that have formed. And so what is really important about the Silurian period, okay, this comes after Ordovician. The Silurian period is where we have plants colonize land, okay? And these are just going to be really basic plants. These are not going to be things that have seeds, okay? So these are seedless plants. Things that essentially do all of their stuff via spores, all right? And they're going to be pretty limited in how far they can go inland due to the fact that they do only do their stuff via spore. And so they'll need some sort of water generally to transport that. So a lot of these were near the coasts that we have these seedless plants. But we do have things starting to move on to land, okay? And that was the Silurian period. Whoop, excuse me. Get that back up. So anyway, the Silurian period is where plants start moving on land. This is the first time we see life on land, not only in the ocean, okay? And to follow that right up, the Devonian period, this is where we start having insects and amphibians. All right, so insects and amphibians move onto land. All right, so the Devonian period is a huge period because now not only do we have plant life, we're also starting to get animal life, okay? And we have amphibians, which are vertebrates, okay? So this is our first direct kind of, we have contact, we are starting to colonize land. Now amphibians obviously need to stay relatively close to water. Without that, they have trouble, okay? And so a lot of this stuff is kind of going on, and the end of the Devonian period results in, finally, another extinction. Okay, so then we have our Devonian extinction. Now, the thing about the Devonian extinction, this only affected marine life. Okay, again, we lost about 50% of marine life. However, terrestrial life, 2 R's in terrestrial. Terrestrial life flourished. Okay, and so we have all these sorts of things happening, and at this point, things in the ocean are going through extinction events. Now, this just means that there are species dying off. Certain species live fine, okay? When I say 50% of life, that doesn't mean 50% of all life. That means 50% of species went extinct, okay? But over time, that just allows for, that's essentially natural selection. Whichever ones are able to withstand these changes, they reproduce and they outcompete and they do better than the other organisms. All right, and so once we've gotten into the Devonian extinction event, this is where life really does start to take off on the terrestrial planet, okay? At this point, we've only had seedless plants and amphibians and some bugs, and they're pretty contained into the coasts, all right? But then we're going to get, and I'm going to go ahead and clear this, okay? Our next one which is a really important period because we are going to get one of the most important evolutionary developments, and this is during the Carboniferous period. Okay? Plants that have seeds form. Okay? This allows plants to move further inland. Okay? So basically, obviously there's some organisms that can carry these. There's not really that many at this point. This would mainly be insects that would be carrying these around, but seeds also can be dispersed via wind and things like that. And so a lot of these plants begin to form. And the kind of plant that you would really start to notice, you're going to see a lot of ferns, okay? Ferns with seeds become dominant plant in this period, all right? So we have all sorts of ferns. Now, the reason that this is called the Carboniferous period is this made the Earth's surface essentially one big swamp, okay? And once that kind of swamp died off, all right, and we'll talk about that. That happens more during this next period called the Permian period. But once swamps began to die off and get buried, this made huge coal beds. Okay, so a lot of the coal that people mine nowadays, coal pretty much comes not exclusively, but primarily from these carboniferous swamps. Okay, so a lot of this stuff that we mine, that we use for fossil fuels, is coming from this time when we made just a whole lot of swamps and a whole lot of carbon. And when that gets all buried and compressed, and that's when you're going to get your fossil fuels, okay? But anyway, so then we have our Carboniferous period. Lots of swamps. The insects are dominating. Amphibians are trying to move around, but obviously they're pretty stuck. They are pretty water-based. They'll go onto land, but they primarily need water, which brings us to the Great Permian period, okay? And the Permian period is where we have reptiles form, okay? So reptiles form, and this allows vertebrates to travel further from water than ever before, and they begin to colonize the solid earth, okay? And so, you know, the more plants that we get, the more insects are spreading out. Once these insects have been spread out, that, you know, if the amphibians essentially are able to be on the ground longer instead of having to be in the water, they have a better chance to outcompete their competition and get more of that insect into their diet. As this happens, you know, gradually they'll kind of work their way to a point where they don't need water anymore, and the amphibians become reptiles, all right? We do not have dinosaurs yet at this point. We'll talk about this, but one of the main differences between a reptile and a dinosaur, reptiles, think of like crocodiles or lizards, their joints go out like this, and they're all sprawled out, walking with both their legs. Dinosaurs are more like us, more like mammals, where their hips were underneath them instead of out to the side. But anyway, we'll talk about that more in the Mesozoic era, which we will get to on Wednesday. But anyway, so we have the Permian period. Now, the Permian period results in, I mean, there's a lot of growth and evolutionary change occurs during this period. Okay. However, to finish this off and to finish off the Paleozoic era, we have the Permian extinction. There we go. Okay, and so unlike the first two, this affected both marine and terrestrial life. So things in the ocean and things on the ground. Okay. About 95% of marine life went extinct. Okay, so the majority of marine life at this time that we had back in the Paleozoic era no longer has made it through. Okay, a lot of organisms died here. It was a pretty big one. Again, this is probably a combination of causes. There was a big drop in sea level. Okay, kind of Pangea forming caused that. Okay, because you're going to get more things rising higher. As that happens, things will start to go lower. You're also going to get 65%. Oh, I put a period there. 65% of amphibians and reptiles go extinct. All right, and about 33% of insects go extinct. Okay, that where we had the at the very end of the Precambrian time, where we had our first mass extinction, the Permian extinction is the world's second mass extinction event. Okay, and so far to this point we've had 5, although again people are starting to think that we might be going into our 6th mass extinction event. Okay, but after we get through this is where we start to get into the Mesozoic era. You're going to get things, dinosaurs, birds, trees, and flowering plants will start to form. This is where we're going to start seeing more of a more commonly what we would think of Earth's life looking like, all right, instead of just one big swamp. Okay, are there any questions about the Paleozoic era?
Nope.
Nope.
Okay, I'm gonna go ahead and stop sharing that, and I will